We have a diagram, triangle ABC, angle bisector intersect the perpendicular bisector at point P, and what I would like to prove that every triangle is isosceles. I'll do some magic.
Okay.
So the trick, be attentive, the trick is coming. Let's
make a mark. It's a perpendicular bisector. Let's make this as so.
Yeah, it's a perpendicular bisector. So I can take the projections PE and PD. So this is point D, this is point E, right? So because MP is the perpendicular bisector, I know that BP is equal to CP, right?
That's the meaning of perpendicular bisector.
Right.
Equidistance. Right?
Every point on this line is equidistant.
Yeah, let me write this down. PM is the perpendicular bisector of segment BC, right? So BP equal to PC, right?
Right.
Yeah, because that's the meaning of perpendicular bisector. Everything on this perpendicular bisector is equidistant to the two ends.
Right. Now let's look at triangles APD and APE. It's an angle bisector. These two angles are equal. These two angles are 90 degrees. These two angles will be also equal. So by angle side angle, I know that these two triangles are equal.
A, right? We always ask our students to write it this way. I think it's good in order to tell people what's the condition. So over here, the first one is you are looking for this two triangle, right?
Right.
So first of all is EAP
is equal to DAP. Side AP is a common
equal to BP.
Yes.
And over here you have
APE,
APE equal to AP. Right? So by side angle side, you know triangle AEP is congruent to triangle ADP. Right? Okay.
Yeah. Which gives us that AD is equal to AP.
AD equal to AP. Good.
Right? And moreover, P is equal to P. Now we have two remaining triangles, CPD and BPE.
Now clearly CD equal to BE, right?
Why?
Because there are two right triangles, they have the same two legs.
Yes.
Hypotenuse and leg,
Yes.
right?
So we can use Pythagorean theorem to prove that BE is equal to CD. So I know that
Circle. Okay, yeah, that's right.
that BE is equal to CD.
Then we find something really interesting. So AB has to be equal to what?
AC.
AC. That's not likely to be true, right? You are telling me all the triangles are isosceles. That's trouble. Because clearly I can draw 3, 4, 5 triangle, which is not isosceles. Right?
Right. So the question to students
is what went wrong.
What
Right?
went wrong?
So the key to this whole section is drawing accurate diagrams. Okay? I talk to my students many times. Drawing diagrams not in scale is not a proud thing you should say. When we do anything, when we do study, when we do future work, research, scientific job, or just regular clerk work, bookkeeping, we always want to say what? We are putting our effort to do it well, right? So drawing an accurate diagram is actually very important, and this is a skill, a technique. Many students just refuse to draw it well, and then they never practice. And then you just practice more, naturally you start to draw very accurate diagrams. And that's the key to study. You want your diagram to tell you information, right, rather than mislead you. Because actually, whenever how poor a diagram you draw, based on the experience I have, all our students actually believe in their diagram, no matter how poor they draw. They look at diagram, they say it's like this. If that's the case, I always tell the students, it's not good to not draw diagram accurately. And it's much, much worse to follow your bad diagrams. Okay? Right? So this is important to know. They are cheating on you. This point actually is not here.
It's not here. That's
right?
the magic.
That's the magic. This point is outside. So what you did over here, lengthwise you are flipped outside. Okay? So that's why we have this section. And the title of this section is Draw Accurate Diagrams, Understanding what Math is About. So what I mean is this. When you draw a triangle, don't draw it this way. You can clearly have a horizontal side, draw it. Or you can clearly have a vertical side, use it. Your eye vision does help you X and Y coordinates much better. And also, eyeball midpoint is not a difficult thing. Don't just randomly say that's midpoint. Or don't just write a triangle like this, claim this is 60 degrees, this is 30 degrees. That's horrible. Because when you do this, when you get numbers, this is 1, 2, and root 3, you could clearly mismark them. Because your diagram tells you this should be the length, and these are the angles you randomly draw. What does that mean? Right? So everything you do, you have to put in effort to see what is going on. Right? So to end about this lecture, well, first of all, in the future, when you learn more geometry, we will prove why this point will be outside after we study circles. Okay? But as for now, you can see a better draw diagram, and you follow the diagram, what can happen? Okay, so this give an example. And then we talk about this. We talk a little bit about folding. Okay, this is very important. You look at a triangle, you should easily pick out what? Midpoint. Right? How do I know midpoint? I should fold them point to point. Point to point, then I know that's a midpoint. And furthermore, what is this mark? What is this?
Oh, you just made a perpendicular
bisector, right? And then even with folding, you will see, how do I fold these two angles together? Be creative, think about it, right? And then you will see this point is really outside of the triangle. Okay? That's one thing. So you have some exercise for you to help you to understand the different definitions. Medians, angle bisectors, perpendicular bisectors, they are very much different. Okay? A good exercise is this. You draw a triangle to practice it. And then you think about the perpendicular bisectors you draw from this. You think about the angle bisector. You think about the median, the altitudes. There are 4 lines coming from here. Right? Where are they? Hey, draw it accurately.
So this is the altitude, right?
Mm-hmm.
This is our median.
Mm-hmm.
This is our perpendicular bisector. And as we know already, the angle
bisector is here. So that's always, this is what is going to happen. Okay? So use your paper well. You should be able to fold out all these 4 lines. I think the most tricky line is how do you fold out altitude. But try and enjoy it. Okay?